Have you ever wondered what it would really take to build a robot that can see, think, and act in the real world? Kind of like us. Well, today we're going to dive into a fascinating new open source guide that's all about teaching anyone exactly that, how to build the minds for the machines of the future. Let's jump right in. So here's our game plan for today. First, we'll break down what physical AI even means. Then we'll look at the actual blueprint this new guide gives to builders. After that, we'll walk through the step-by-step learning journey, check out the software toolkit it uses, and you're going to want to stick around for the end because there's a fascinating twist on how this whole guide was even created.
Most of the AI we interact with, it lives in the cloud, right? It's busy mastering games or writing emails, but the next massive frontier is taking that intelligence out of the digital world and putting it into our physical reality. That's the whole idea behind physical AI.
And that, right there, is the million-dollar question. I mean, it's one thing for an AI to just process data in a server somewhere. It's a whole other ball game for it to actually perceive and reason and act in our messy, totally unpredictable world. So how on earth do you do that? Well, the answer lies in this field, sometimes called embodied intelligence. It's all about creating systems that don't just crunch numbers, but actually experience the world directly through a physical body. And that is the huge leap from just digital thought to real-world action. Now, this sounds super complex, but you can really break it down into three core parts. First, you've got sensors, think cameras and microphones, which act as the robot's eyes and ears. Then you need actuators, all the motors and joints, which are basically its muscles. And this is so critical. You need a digital twin, which is like a virtual practice arena where the AI can learn and fail safely before it ever tries something in the real world. And that brings us to the reason we're talking about this today. This isn't just theory anymore. It's a practical, open source guide designed to show people how to actually build these systems right from the ground up. And here it is, Physical AI Humanoid Robotics. Now, yeah, it's a technical guide, but the thing that makes it so important is that it's designed to be beginner-friendly. The whole goal here is to crack open this incredibly advanced field for a much, much wider audience. So who's it for? You might think you need a PhD in robotics, but not really. It's actually heavily aimed at students, developers, and AI coders who already get machine learning and just want to apply it to the physical world. All you really need is some basic Python and AI knowledge to get started. Okay, so let's say that's you. What does the journey actually look like? Well, the guide lays out a super clear, structured path to take you from your very first line of code to a fully working robot. Let's be real for a second. The idea of building an autonomous humanoid, that sounds incredibly intimidating, right? But the whole philosophy here is that you can tackle any ridiculously complex problem as long as you break it down into smaller, logical, manageable steps. And this guide lays out a really clear 5-step path. You start with the foundations. Then you build the robot's nervous system using a framework called ROS2, which is what lets all the different parts talk to each other. Step 3 is super important. You practice in those digital twin simulators. Then you start integrating the big language models to give it a brain and ears. And it all leads up to the final capstone project, building your own complete voice-controlled humanoid. Now, to walk that path, you obviously need the right tools. And we're not just talking about screwdrivers and metal parts. The software is really what brings these machines to life. So let's take a look at the modern tech stack that powers this whole thing. The tech stack is built on a few really key pieces of software. ROS2, like we said, is the nervous system. Gazebo and NVIDIA Isaac, those are the virtual training grounds. Then you have OpenAI's models like GPT-4 and Whisper, providing the high-level reasoning and voice recognition. That's the brain and ears, and the glue holding it all together is Python, the main programming language for the whole project. Okay, so we've covered the what and the how, but the most surprising part of this whole story, it isn't just what's in the guide, it's how the guide itself was created. This is where things get really, really meta. Just take a second and read that. This entire comprehensive, beginner-friendly guide about building physical AI was itself written by an AI. Yep. A human provided the detailed specifications and the overall plan, and then an AI generated the text, the code examples, pretty much the whole structure. This is a complete game changer. I mean, think about the traditional way of writing technical books. It's slow, it's manual, it's totally bottlenecked by how many human experts are available. In this new workflow, the human expert acts more like an architect, and the AI is the builder. This allows for an incredibly fast and scalable way to create and share knowledge.
So here it is, the big takeaway. We are watching a really profound shift happen. AI is no longer just the thing we're trying to learn about. It's actively becoming the tool that teaches us, basically writing its own manuals and making incredibly complex knowledge accessible to everyone.
And that just leaves us with a pretty massive question for the future, doesn't it? As these AI systems get better at not only doing the tasks, but also teaching others how to do them, what does that mean for our role? It really suggests a future where we shift from being the sole creators of knowledge to being more like conductors or collaborators in its creation. What do you think that future is going to look like?